Hello everyone, welcome back to my channel Learn Math with Priti. The topic which we are going to study today is Surds. So let's start. So the topic is Surds. Now, what do you understand by this word Surds? First we need to understand what are Surds. Then only we'll be able to study Surds, right? So what are Surds? Surds are also some numbers only, right? In maths we always deal with numbers, so surds are also a type of numbers only, but here surds are some numbers for which roots are not possible, or we cannot get the roots as a rational number. Okay, I hope we all remember what are rational numbers. Rational numbers can be fractions, whole numbers, terminating decimals also, right? So when for any number the root of any number is not a rational number, that is not a rational number, that becomes a surd. This is in a mathematical way, in simple way, a number whose root is not possible to find out, that becomes a surd. We can also say that the surd is a root that cannot be simplified into a whole number. So when you cannot simplify something into a whole number, that becomes a surd. Okay, so now we will take up some examples which are surds and which are not. We will try and understand that first, right? So if I say root 16, okay, what is the root of 16? We all know it's 4. So square root of 9 is 3. So as you know, 4 and 3, are these rational numbers? Right. So they cannot be surd. As I told you, we cannot find the root as a rational number. So these are not surds. Surds are number like root 5. Is it possible to find the root of 5? No. So it is a surd. Similarly, root 3, root 7 or cube root of 10. Not necessary it is always square root. It can also be cube root. Okay. So cube root also can be a surd. Cube root can also be called as a surd. So if you see square root of 3, square root of 7, cube root of 10 or square root of any other number, say suppose 20, is not possible. So all these are called as surds. So I hope what is surds is understood quite well, right? So now when we study numbers, fractions, decimals, after knowing what are numbers or decimals or fraction, what do? We just move on to the calculations with that, right? So similarly, here also we need to do the calculations with the surds. So the next topic for us is calculations with the surds. Now how to do calculations with the surds? We need to understand, right? Calculation with surds. Okay, so just as we do calculations with decimals, fractions, whole numbers, rational numbers, we can also perform the calculations with surds also. Surds come under indices because the calculations part is similar to that of the indices which we did in our previous video, right? You can check out over there. So how we have certain laws for indices, similarly we have certain rules to solve these surds. So there are two rules for solving surds. Okay, what are the two rules? We will write down the rule. First is multiplication rule and second is division rule. Okay, so there are two rules. First is multiplication and the second one is division rule. So how do we solve multiplication rule and division rule with surds? We will see that. Suppose we have two numbers, root 5 into root 7. Okay, both the numbers, root is not possible for both the numbers, right? Because both of them are surds, right? So what do? Multiplication rule tells us that if there are two numbers, there are two surds in the root, same root, this is in the square root, this is also in the square root, then you can just multiply them. So we can simply multiply 5 and 7, we can write square root of 35. Okay, so this is the multiplication rule. This multiplication rule says that when there are two surds and they are in multiplication and they have the same square root, both are in square root, then we can just simply multiply both the surds. Similarly, division rule. The same thing applies to division also. Root 5 upon root 8, again both are square root, and the root for both of them is not possible, right? Square root is not possible. So we will write root 5 upon 8. Here you cannot simplify further, but sometimes it's like 25. 25 is actually, we can find out the root. So let's not take up this example. So this example or any other surds which is in fraction can be written under one root. Okay. So this is the multiplication rule and the division rule of calculations with surds. Okay. Now generally after these rules, these rules are being used actually to simplify the surds. We simplify surds based on this rules only. Okay. So how do we actually simplify surds? So let's take up some examples so we'll understand how do we actually simplify the surds. Okay. First example, I'll take a small number first, square root of 18. Okay. Now we know that square root of 18 is not possible because 18 is not a square number, right? It's not. But can we simplify this 18? Can we write 18 as a factor of two numbers? Right? So always try and get two factors of the number given in such a way that one number will be a square number and the other number cannot be a square number. Okay. So for example, when you find factors of 18, there are many factors of 18, right? First, 2 9s are 18, then 3 6 are 18, then any more factors? No, only these two, then 18 ones are 18. So which factor to use, 2 9s are or 3 6 are, that depends upon us. So as I told you, try and use a factor, two factors in which one is a square number and the other is not. So if you see 2 9s are, 9 is a square number and 2 is not a square number, right? So we are using that factor. So I'll write root 2 into 9. That means 18 can be written 2 9s are, right? Okay, now square root of 2 is not possible. But is square root of 9 possible? Right? Yes. Square root of 9 is 3. So if I write like this, 2 into root 9. Because previously we saw multiplication rule, right? When there is a surd and we have two factors, we write them under one root. So I am just using the reverse of that. So I am writing root 2 into root 9. So the root of 9 is possible because it's not a surd. Okay, it's a perfect square number. So what is square root of 9? It's 3. So I'll write 3 as it is and root 2 will remain as it is because the root of 2 is not possible only. Okay, now let's take up the second example. A little bigger number we will take. Okay, let's say 75. So 75, square root of 75. So square root of 75 also has many factors, like it comes in the table of 3, 5 and so on, many tables. Okay, so first 25 we will take. Square number we want to take now. So 3 into 25, right? 25 3 is 75, right? In which one is a square number and one is not. Because if we take any other number, suppose 5, then we are not getting the square number. Okay. If I divide this by 5, so I will not get a square number. I'll get 15 into 5, right? But in that 15 and 5, both are not square number. So of no use. So I will take the factors such that one is a square number and one is not. So again I'll write them root 3 into root 25. So root 3 is not possible as you all know, but root 25 is possible, right? Root 25 is 5. So we will write 5 root 3. So this is simplification of surds. So surds are given like this. We can simplify it to the form till which is possible. Like how we used to have numbers in fraction, they used to tell us simplify to the lowest term. So we used to do it the simplification. Similarly, surds are also simplified like this. Just one important point one number should be a square number and the other should not be a square number. Okay, this is the one important point to keep in mind when you simplify the surds. Very simple. Now simplification of surds, after that we will have to also rationalize the denominator. Sometimes not necessary that every time surd is given as a number. Sometimes surds can also be given in fraction form, right? So if the surd is given in fraction, always remember the denominator cannot be a surd. You are trying to solve something and the denominator comes in the surds form. You cannot keep it like that and leave the answer. It's totally wrong. So what do? We try to remove the surd and get a proper number, or we try to eliminate the number which is in the denominator. That is to be done. So we never keep the surd in the denominator. So if suppose I'll take up an example, 2 upon root 8. Now as you see in the denominator, up there is a whole number but down there is a surd. So we cannot keep, they have told rationalize the denominator. So we will rationalize, means we will get a rational number in the denominator. Okay, that's why they are telling rationalize the denominator, because it's having a surd and we need a rational number. So what do? Just multiply whatever surd is there, just multiply the numerator and denominator again with the same surd only. Okay, so the surd is root 8 here. So just multiply both numerator and denominator with root 8. Okay, so in the numerator I'll get 2 root 8 and root 8 into root 8 will become 8, right? Because root 8 into root 8 gives us root 64. What is the root 64? It's 8. Now can you simplify any further? Yes, 2 1s are, 2 4s are. So this is root 8 upon 4. Now can you see we have rationalized the denominator. That denominator is a rational number now. Okay, so this is how you rationalize the denominator. We will take one more example which is a little tricky to understand. If I say 5 upon 4 root 10. Now here many people get confused and what do? They just multiply 4 root 10 both to the numerator and the denominator. Please keep in mind we only multiply the surd. Only and only the surd part we will multiply, because number is there. Already we want to rationalize the denominator. So 4 is already a rational number. So no need to move that and no need to change that. We just need to move the surd. So always remember, don't multiply the number, just multiply the surd with the numerator and the denominator. So what I'll do again, 5 into root 10 upon 4 root 10 into root 10. So in the numerator I get 5 root 10 and in the denominator I get, as I told you, root 10 into root 10 will give me 10. 4 tens are 40. Now can I simplify it? Yes. So my answer becomes root 10 upon 8. So these are the two types of rationalizing the denominator. If there is a single term, there can also be rationalizing with multiple terms in the denominator which are separated through plus or minus sign. Okay, so always and always remember, you just multiply to rationalize, you just multiply the surd and not the entire number which is given in the denominator. Don't multiply it with the entire denominator, only multiply it with the surd which is present in the denominator, not in the numerator also. The surd which is present in the denominator. Okay, now we will do more questions of rationalize, but here in this there will not be a single term in the denominator. There will be a two terms and they will be separated through a positive or negative sign. So the question is 2 upon root 2 minus 1. Okay, in this, if you see the question, the denominator is not having one term, it is having two terms. There is a surd and a number. They are separated by a sign, that is a negative sign. So again we have to follow the same step. We will multiply it with the denominator only, but you cannot just multiply it with the surd here because it's totally one term. So we have to multiply with the same term, but we conjugate the term. Conjugate means we just change the sign. Instead of minus, it becomes plus. We take the same term but with the different sign. That is the opposite sign. So again, we'll multiply the numerator with root 2 plus 1 and also the denominator with root 2 plus 1. So when you multiply, what do you get in the numerator? 2 bracket root 2 plus 1 upon, this becomes root 2 square. This is a minus b and a plus b, right? You remember a minus b and a plus b. What does it give? It tells a square minus b square. Very important. Okay, so this becomes root a is root 2 and b for us is 1. So root 2 square minus 1 square. So this becomes 2 root 2 plus 2 upon root 2 square will be root 2 into root 2, that is root 4. What is root 4? It's 2. So 2 minus 1. So 2 minus 1 is 1. So the answer is 2 root 2 plus 2. Simple. Now not necessary in the numerator you have a whole number or a rational number only. You can also have a surd also in the numerator. So let's take up one more example which is having a surd in the numerator, and how do we solve that? 7 root 3 upon 2 root 2 plus 5. Again, as I told you, rationalize the denominator. That means we need to move the surd, but surd is with the entire term, so we will multiply the numerator and the denominator with the entire term, but just a slight change. We will just conjugate the sign. This plus will become minus. So this becomes 2 root 2 minus 5 upon 2 root 2 minus 5. Okay, so the above numerator will be like this and the denominator this. Again, this is a and this is b. So this will be 2 root 2 the whole square minus 5 square, right? So I'll just open up the brackets here. We'll multiply the whole number. 7 2s are 14, and we can multiply the surds. Root 6 minus 7 5s are 35, and root 3 will be as it is because there is no surd with the root number 5. Okay, now this is 2 root 2 square. So 2 square will be 4 and root 2 square will be 2. 4 2s are 8 minus 5 square is 25. So what do I get? 14 root 6 minus 35 root 3 upon 8 minus 25 will be minus 17. Now you cannot leave the answer in the denominator in negative, so we just keep the negative sign here. We put it here. So if I negate the entire term, this 35, let's take this here. This entire negative will bring it up. So this will be in negative then. Okay. Upon 17. So what will it happen? This 14 root 6 will become minus and 35 root 3 will become positive. So I am writing 35 root 3 first minus 14 root 6 upon 17. Now if you see, the denominator is not negative, neither there is a surd in the denominator. So we rationalize the denominator and there is no negative sign also in the denominator. So after rationalization, we got this as the answer. So that's it for today. I know the surds are a little challenging for everyone. We'll just take up the last challenge question. Please solve the question and give me the answer. I will check the answer for sure. Also, I will give you the correct answer once I get any one answer also from anyone. So this is a little tricky one. Please try and solve this challenge question and write the answer in the comment section below. So that's it for this topic, surds. See you all in the next lecture. Till then, thank you for watching.